Okay, we finally made it to the last section. So optimizing over several functions. So now, the reason why we learned all those partial derivatives, the first and the second partial derivatives, was to be able to do this section. And in this section, what we want to do is maximize and minimize profit, for example. So it's going to be very similar to how we did it with one variable by using first and second derivative tests. It's a little bit more convoluted, and the problems can get really messy because then it will require us to use like substitution and elimination to solve a system of equations. So what we're going to do is we have a surface, okay, z equals f of x comma y, and what we want to do is find the relative minimums, maximums, and saddle points. So we did a video on that of what that looks like, so you can go ahead and take a look at it. So using these techniques will help us find profit, which is what we're going to do later on. So in order for us to do that, the first thing that we want to do is find critical points. So if you remember how we found critical points when we were in 2D, we just take the derivative and set it equal to 0, and we solved. And another way that we can do it is whenever the derivative is undefined. Okay, so for the sake of simplicity and for this class, we're going to ignore the undefined for now, but it is possible to do it because it can get a little messy. But we're going to only look at when the partial derivatives are equal to 0. So now we have two different things that we got to worry about. We got to worry about two derivatives and two equations that we need to solve for. Okay. So, like I said here's an FYI. It is also true for when the first derivative is undefined. And pretty much what's happening is that imagine that now instead of having a line, so if you think about a function, and we think about derivatives, you can see the derivative is increasing, and 0, decreasing, 0, increasing. You can see that whenever it's 0, you're going to get maximums and minimums. Same thing can be said in 2 dimensions. I'm sorry, in 3 dimensions. So now we're in the 3D case. You can see that all of the derivatives or all the partial derivatives are increasing, but at the very top, you got a 0 in the x direction and a 0 in the y direction. And I totally flipped that around. Okay. All right, so the derivatives itself at the maximums and minimums are going to be wherever the derivatives are 0. Okay, so we have to find critical points, which set m equal to 0 and solve. Now to find whether something's a minimum, maximum, or saddle point, what we did back in chapter 4, we did the second derivative test, right? And this guy, basically what it did, it tested concavity. So whether something was concave up, so you can see that if it was concave up, you can kind of see that it's a maximum. And if something was like concave down, then you can have a minimum there. So the way that it works in 3 dimensions, it's very similar, but it's a lot more convoluted. And we call it the DTest. So the DTest is this crazy thing. Now, you don't need to memorize this, but it's a list of conditions. So in order for you to do the DTest, you have to do a couple of things. So the first thing is that we got to find our critical points, and then you got to find this D, okay? And a short way to write this D, I like writing it as f sub x, x, f sub y, y, minus f sub x, y squared. So I like to write it like that instead of writing the a and b. So you're going to come up with this equation. Now, this equation, it does come from somewhere. It comes from linear algebra, which is Math 254, which none of you guys have to take, at least for this class. But it has to do a lot with matrices. So just know that it does come from somewhere. Don't worry so much about the proof. All you got to do is figure out what this D is and then plug them in. So here I have a list of conditions. So if D is positive, and the second derivative with respect to x is positive, then you got minimum. If D is positive, but now the second derivative is negative, then you got a maximum. If D is negative, then I don't have to test the second derivative, and I can just say it's a saddle point. So it's not a max or a min. If d is 0, we got to do something else. We got to use some sort of software to be able to figure out what exactly is happening at that point. So something's up. My DTest failed to do that. So in addition to the DTest, I gave you guys here a list of steps in terms of what to do. The first thing is that you want to take the partial derivatives and set them equal to 0 and then solve for them. So you do have to keep in mind that you might have to end up with a system of equations and you have to use substitution or elimination. Okay. Then you want to take the second derivatives after you find your critical points and plug the partials into the D formula, the D-test. And finally, after you do that, you want to plug in your critical points that you found in the first part, so in part 1, and then you're going to use these rules to classify them. So if you want to find the maximums and the minimums, you want to plug them back into the original. So that's how you're going to find what is the maximum point and what is the minimum point. Okay, so that's how you would go ahead and go about that. Okay, so it's a little bit of a long process, but it's doable. Okay, so let's go ahead and do a couple of problems. So here we want to find the relative extreme values of this function. Okay, so it looks really crazy, but we can still do it. Okay, so the first thing that we want to do is we want to take the partial derivatives with respect to x and y. Why? Because remember that we want to find the critical points. Okay, so we're going to take the partial derivative with x, partial derivative with y. So partial derivative with x, notice that this guy's going to give me just 2x. Then this guy's a constant, so it goes away. The other guy is going to be 2y. This guy's just going to give me a 2. And then the other ones are just 0. Okay, so I'm going to go a little faster on the derivatives because we have been doing them over and over again. Right, so 2x plus 2y plus 2. And now we're going to take the partial derivative with respect to y. So the first one goes away. The next one's 4y. Then you have this 2xy. That's just going to give me a 2x. This guy goes away, and you're left with a 4. And we're going to set that guy equal to 0. All right. And now at this point, notice that we do have a system of equations. So we need to solve for one of the variables. Okay. So the one that I'm going to do is I'm going to solve for, I don't know, for x or y. So I'm going to subtract 2 over 2x plus 2y equals negative 2. Okay. I'm also going to subtract it over here. Minus 4 minus 4. So I'm going to put the 2x in the front first, plus 4y equals negative 4. So here you can do one of two things. You can just use substitution, solve for one of them, and plug it into the other guy. You can use matrices if you want. That would be kind of horrible. Or you can just use elimination. So if you remember, elimination was eliminating one of the variables. So what I notice is that these two x's are the same, but I need one of them to be negative. So I'm going to multiply this whole guy by negative 1. And what I'm going to get is I'm going to get negative 2x minus 2y equals positive 2. So this goes away. I'm left with 2y equals negative 2. So y equals negative 1. Okay, so we got our first y value. And now in order for me to find my x value, its partner, I'm going to plug it back into the other one. So I'm going to have 2x plus 2 times negative 1 equals negative 2. So you're going to have 2x minus 2 equals negative 2. Add the 2's over. So 2x equals 0. So x equals 0. So you can see that my point is going to be 0, negative 1. This is my only critical point, my CP. Okay, because I didn't get anything else. So this is either going to be a minimum or a maximum, or I don't know what the heck this is. Okay, so now what we want to do is what? So we just took the partial derivatives and we used elimination. You could use substitution as well. Second step, so this was the first step. My second step is to take the partial derivatives. The second partial derivatives. So I'm going to look at my f sub x, which was this guy. before I moved it over, and my f sub y before I moved the 4 over. So now I'm going to take the second partial derivatives. So f sub x. So I'm going to take this guy and take the derivative of x again. That guy is just going to give me 2. What about f sub y? Well, I'm going to take this guy that I have here, take it with respect to y. Notice that that's going to give me 4. And then f sub xy. Notice that they're going to be the same thing, so I can use whichever I want. So I'm going to use the f sub x, and I'm going to take the derivative with respect to y. That's going to give me a 2. Okay? So now I found my guys, and what I'm going to do is plug them into the D formula. So the D formula is this guy, this crazy stuff up here. So I wrote here the shorthand notation without having to do the A and B. So I'm going to write down D is equal to f sub xx times f sub yy minus f sub xy squared. So notice D is going to be equal to, let's plug everything in there. So you're going to get a 2, you're going to get a y, 4, and you're going to get another 2 squared. So you're going to get 8 minus 4. This is going to give me 4. This is a positive number. D is positive. 4 is greater than 0. So let's go back up. So right now we are in step number 3, I think. Yeah, we're in step number 3, plugging it in. Okay, so we got 4. 4 is greater than 0. Notice that there's nothing to plug in. I can't plug in the 0, 1 because there's no x's. Now, don't feel like you need to have an x. In the next problem, you'll see that you don't really need to have an x to do this problem. But here, you can see that you got 4. Okay, so I'm already classifying this guy. So it's positive, D is positive. So we got this D is greater than 0. So that means you can either have option 1 or option 2. D is greater than 0, D is greater than 0. So it's either going to be a minimum or a maximum. The one that's going to decide is the second derivative test. That's f sub xx. So let's look at f sub xx. F sub xx is equal to 2. That's also a positive term. Okay? So that means this guy is positive. They're both positive, so what does that mean? When both of these guys, f sub xx and D is greater than 0, then you got a minimum. So 0, negative 1 is a minimum. And that's what we get for that guy. Okay, cool. So again, when you do your D, okay, sometimes you're going to have x's and y's, sometimes you're going to have nothing. So, and usually what happens is when you don't have any more variables is because typically you only have one critical point. Okay, usually that's when that happens. Or when you only have squared functions. When you have squared functions and everything else is just ones, then you kind of get this weird D. Now, what happens if you have x's and y's? What would you do instead? And this doesn't classify itself. Oh, wait, we're not done yet because we still got to plug it back in. We've got to plug in f of x, y back in. Okay, so we're going to have f of x, y. So I'm going to plug in 0, negative 1. Oh, let me write down the function again. Okay, so let's plug it in. So f of 0, negative 1. So the first guy is going to be 0 when I plug it in, plus 2 times negative 1 squared. The next one's going to be another 0. Then you're going to get another 0, plus 4 times negative 1, plus 7. Okay, so plugging all the 0, negative 1 in here, I'm going to end up getting a positive 2, a negative 4, and a positive 7. So you're going to get negative 2 plus 7. So this is going to be a 5. So 5 will be the minimum of this particular graph. Okay, so now let's do something that's a little bit more involved. So for example, this guy, finding the relative extreme values of this particular function. So now we have a cube, so things are going to be a little different. So again, let's do the same thing. We're going to take f sub x, and we're going to take f sub y. So taking the derivative with respect to x, that's going to give me negative 2x minus 2. That's going to be f sub x. Everything else is a constant. F sub y is going to be 3y squared minus 12. Okay. And now what we're going to do is we're going to set them both equal to 0. Okay, so we can solve these guys. You're going to get negative 2 equals positive 2. So x equals negative 1. And here I'm going to move the 12 over. So get 3y squared equals 12. Divide by 3. You get 4. So y equals plus or minus 2. So notice that because we got two separate ones, these are just going to be the combinations of each other. So my critical points, now we got two of them. We got negative 1 with a positive 2, and then negative 1 with a negative 2. So these guys are my critical points. Okay. All right. Now that we got that, the second step is to find the second partial derivatives. So I know what f sub x is. That's negative 2x minus 2. And I know what f sub y was, which is 3y squared minus 12. So the second partial derivative with respect to x, in this case, will be negative 2. The second partial derivative with respect to y, in this case, would be 6y. And now I got to do the mixed partial of xy. So I'm going to take this guy, this negative 2x, and I'm going to take the derivative with respect to y. Notice that there's no y, so everything goes to 0. So now let's plug this into the d value. So d is equal to f sub xx, f sub yy, minus f sub xy squared. So you're going to have negative 2 times 6y minus 0 squared gives me negative 12y. So d in this case is negative 12y. Notice that in this case, I didn't get an answer. Okay, I actually have a function now. So that means, and that usually happens when you have many different terms. So what that means is that I got to plug now, in step number 3, plug each of these critical points to see what they are. So the first thing that I'm going to do is I'm going to test the point negative 1, 2. So I'm going to plug it in there. T equals negative 12 times times y. And what I'm going to do is I'm going to plug in the point. Now, the only thing that I can plug in is the 2. This gives me negative 24. This guy is negative. When the d is negative, what am I going to get? So let's go back up. So when d is negative, you can see that you're going to get a saddle point. So we're going to go down. You're going to see that this guy is going to be saddle point at negative 1 and 2. So now we're going to plug in the next one. Negative 1, negative 2. So d equals negative 12 times negative 2. That gives me positive 24. So now it can either be a minimum or a maximum. So remember, what we got to check is now the second partial derivative with respect to x. You can see that that guy is negative. So if you go back up, when d is positive and f sub xx is negative, you go all the way back up, you can see that that guy is going to be a local maximum. This guy gives me maximum at negative 1, negative 2. Now, if you really wanted to know what exactly the maximum was, because it is a relative extreme, the saddle point, we don't really care. Unless you really want to know what the z value is, you can. We care more about the extremes, and the extremes are the minimums and maximums. So what would we do? We would just plug in this number back into the original. So if you look at the original, what was the original function? What it was. So that's f of x comma y equals y cubed minus x squared minus 2x minus 12y. And what we're going to do now is plug in everything, the maximum point. So in this case, it will be f of negative 1, negative 2. So we're going to have negative 2 in there. cubed minus negative 1 squared minus 2 times negative 1 minus 12 times negative 2. So let's plug that into our calculator. Negative 2 cubed, minus negative 1 squared minus 2 times negative 1 minus 12 times negative 2. Okay, I got 17. I hope that's right. Okay, let's see if I got that right. 12 times negative 2 minus 2. Okay, I think this should be right. Okay, so this would be my maximum. This is where my maximum point is at. Okay, so that's how you would do these problems. This is kind of the gist of it. So again, they're not too terrible, but they can be a little bit time consuming.